This is a screencast for section 5.3, example 3, theorem 3, the mean value theorem for derivative definite integrals. Mean value theorem right here. Another one of those theorems that you got to know what it is, what it means, how to use it, etc. If f is continuous on a to b, then some point c in a and b is the average value. Is 1 over b minus a times the antiderivative of a to b of f of x dx. In other words, if you take the whole area and divide by the span of x values, you get the average y value. And that just kind of makes sense. If you look at this picture down here in example 3, if we take every single one of these y values and add them all up, so infinitely many y values, and add them all up, their little widths are teeny tiny, and divide by the span that they cover, you'll get the average y value. So average value does mean average y value. Alright, so find the average value of f of x equals 4 minus x squared on the interval 0 to 3. Does f actually take on this value at some point in the given interval? Okay, so first of all, let's find the average value. So the average value, according to our little theorem here, is going to be 1 over the span of x values, so 3 minus 0, times the integral from 0 to 3 of f of x, or 4 minus x squared dx. So I used my calculator because I don't know how to find that integral just yet. We will soon, but I don't now. I know how to use my calculator, find the integral from 0 to 3. So I have 1/3, and then times this is 3, so my average value is actually 1. So then the question is, does f actually take on this value at some point in the given interval? Well, yeah, you can kind of see that it does right there. The square root of 3 actually gives on that value because the square root of 3 squared is 3, 4 minus 3 is 1. But really, this satisfies the mean value theorem. F is continuous, so therefore there has to be that point C. So does f actually take on this value? Yes. F of x takes on the value of 1 because f of x satisfies the mean value theorem. It is continuous. Now try problem number 11. Says use NINT, that's your calculator, to find the average value of the function on the interval. At what points in the interval does the function assume its average value? So let's first find that average value. 1 over b minus a times the integral from a to b of f of x, or y in this case, dx. So I used my calculator and I got 4 point whatever to the negative times 10 to the negative 14th. So for all intents and purposes that is 0. That's just a kind of a calculator error there. So I get 1 over square root 3 times 0, which is 0. So the average y value between 0 and square root 3 of x squared minus 1 is 0. Now, does it actually, at what points does it take on the average value? Well, let's find out. Let's set the function equal to 0 and find the x value that makes that happen. If I take the square root of both sides there, I do get plus or minus 1 for the x value. So what points are they? Well, negative 1 is not in our interval, so I can actually just ignore that one. Positive 1 is in our interval, so the point is 1 comma, let's see, 1 squared minus 1 is 0. And duh, we already knew that. What value does it take on? It takes on 0.